21st. And the next event will be talking about the Phala Encode hackathon. So yeah, we're going to invite a community developer called Joshua Waller and invite him to our event to share about his experience and thoughts, and his work he have done for the hackathon. Yeah, just in the recent weeks, starting from early this month, we are hosting an hackathon with Encode Cloud, and it is a part of the Polkadot Encode hackathon series. And we are one of the ecosystem project joining the hackathon. And actually, I think we're pretty unique in this hackathon because we offer something called the confidential smart contract, and it's really different from the others. And I think there are three interesting characteristics. First is on our end is privacy preserving. That means you can store any secret data or like API keys or privacy data in a smart contract, and this is unique. Another thing I think is very interesting is the HTTP service. So basically, I think we are the first blockchain natively support to send out the HTTP request from the smart contract. This is only possible because of our unique architecture. We run the smart contract just like traditional cloud. And I will also mention this in the following talk. So you can send HTTP request and you can receive the response. You can create asynchronized computing task to run some very computation extensive code within the smart contract, and these are all natively supported. Yeah. So and there are some very interesting use cases built on top of our confidential smart contract. So for example, in the next tech talk, Joshua is going to share about his project, like combining Phala Network and RMRK, the NFT platform on Polkadot and Kusama, to make some interesting interaction. Like you can send requests to RMRK and get the result, and also process the result in the smart contract. And just in our demo, we also have a BTC price bot. So basically, you can send a request to get the latest BTC price and also redirect the price to a Telegram bot. And this is possible because we can also store the Telegram API key in the smart contract. And this is, I think personally, I think this is really, I think probably this is the first time some smart contract network can do that. Yeah. All right. Okay. So far for this. So let's back to the topic. The main topic we're going to talk today, that is about mining. So the problem, and now we call Phala Network the Web3 cloud. And if we're talking about cloud, it's not compared with other blockchain. We compared with the traditional cloud providers. So let's say what are the roles involved in a traditional cloud. So basically there are two roles. One is the servers. So for example, if you run some deploy some application on a traditional cloud, the first thing you're going to do is to just rent some server from the cloud, and then you deploy your application in the server. Usually it's done in a virtual machine. And another role is the platform itself. So besides the server you are interacting with, there are also the platform hosting all the, like the front end and the back end of the cloud itself. It's used to organize the servers in data centers, and it's also used to do the accounting job. So basically, how much money you have spent in the cloud, right? So if we're going to build a cloud for the Web3, so what roles are we going to have? So we also have two roles. First one is the workers. That is just similar to the servers in the traditional cloud, but this time the workers can be run by anyone in the world, around the world. So basically, as long as you have the capable hardware, you can join the network to become a worker. And the workers are responsible to run the applications. They run these apps off the blockchain. It's not on the blockchain. So it can have a really large amount of the workers. And now if you check our app, here we have the analytics page, and you can see now we have 10,000, more than 10,000 online workers. And if we also count these workers that used to be online, it's up to 17K. That's pretty much. Yeah. So that's workers. And we also have the blockchain. The blockchain is considered as a very reliable way to organize the network, and it's very good at accounting. So like you run the workers and you get paid by the network, and you are the developers, you pay to the network, the blockchain, to deploy your applications. So that is nearly identical to traditional cloud. We have the blockchain to replace their platform. We have workers to replace their servers. And yeah, if to visualize the network topology is like this. So on the left top corner, this is our blockchain, and we have a lot of thousands or even 10,000s of workers, and these workers are running in parallel around the world. So the problem is that how do we organize the network? And eventually, I think it's just like what I mentioned, the developers should pay the network, and the network should pay the workers, and of course, these miners. But in the beginning, we still don't have any developers using the network. We need a process to bootstrap the network to onboard these developers. So before these developers get onboarded, we still have to attract as many miners as possible to make sure the network is ready to serve them. So we call this process a code bootstrap. So before developers are grown, we should have some subsidy for the miners, and they just keep online and keep the worker in the good status, and we pay to the miners. And we call this the subsidy, and it's also built in our tokenomic. And on Phala, we have 10 million Phala just for the miner reward. And on this should be Phala. And on Phala, we have much more higher reward because it's supposed to be a much more major network. And this process is called mining. So what should we care about in the mining process? The first thing is that all these miners are not equal. Like some miners may have very powerful machines, but some miners may have some low-end machine. They are all good because maybe some application just need a lot of low-end machines, but some application requires very high-end machines. So to distinguish them, we have a mechanism called performance test. And yeah, this is basically a process to measure how powerful your machine is. So the more powerful the machine, the higher reward you can get from the subsidy. But for the low-end machine, you still have the room to get rewarded. So that's equal. I mean, that's fair. Yeah. And another thing is very important is to make sure the quality of the service. To put it simple, like if we are going to provide the service to some developer, then the developer, of course, they want the application can run smoothly. They don't want maybe some miner just shut down their machine, and then the application will be disturbed. And of course, we don't want that happen. So to ensure the quality, we basically introduce something called SLA. So if you check Wikipedia, then you can get the definition. An SLA service level agreement is a commitment between a service provider, that should be the miners, and the client, that is the developers. So if you commit to mine on Phala network, then you commit to maintain some very basic level of availability and connectivity. And if you cannot meet the minimal requirements, then you may get punished. And that's why we need staking. We ask all the miners to stake a few amount of the token, and the more amount you stake means that you make a bigger commitment and people may trust you better. And whenever you make anything bad to the network, and we're going to slash you. And the more commitment you made, the more slash will be performed on your stake. So this is the very, very high level understanding of the requirement of the mining. So now it's already possible to design a very minimal version of the mining. So basically, because we need staking, and the staking is related to how much you stake in the network. So before mining, we have to do something to measure how much you're going to stake and how powerful is the miner. So before mining, we have two processes. One is register, another is benchmark. Actually, the benchmark just happened right after you register your worker on the blockchain. And let's just take a look at what a register look like. So here I'm showing you the blockchain explorer. So this is kala.subscan.io. And as you can see, if we browser the extrinsic this page, then we can filter out some specific transactions people sent to the blockchain. So here I can filter these transactions. For example, here we have Phala registry, and call means the actual transaction. So here we have let's just limit to register worker. And then as you can see, these are all the transactions for registering the worker. And if I expand the details, you can see the transaction has a lot of parameters. For example, it has the keys, it has the machine ID, it has the operator, and operator I will mention that later. But the public key identify the identity of your worker. So whenever you create a mining session, it creates a public key, and this key will be used in all the future mining process. Yeah, and we also do something called the remote attestation. So here we have the attestation. There are a lot of parameters, not human readable, but if you check, this is actually a JSON payload, and this is returned by Intel because we use the Intel SGX technology, and you can check the response from Intel. And just for this, it shows configuration and software hardened needed. So you got a lower level of the confidential confidence level. But if you got OK, you can get higher confidence level. Yeah, so basically, as you can see, every a few minutes, there are some miner joining the network, and they will call register worker. And right after the register worker, something will happen. It will start the benchmark. And the benchmark result is well, we don't have the diagram here, but it's okay. So benchmark just it's just like after you register the worker on the blockchain, then the P runtime, the mining client, will try to run some benchmark locally. It basically runs some algorithm, just loop over the algorithm and check, giving a fixed amount of the time, a fixed period, and how many iterations it can run locally. So the more powerful, the higher iterations you can get. So that is the benchmark. And after that, the miner is going to post some report back to the network. And if we check, it's happening here in Phala MQ and sync off-chain messages. But sync off-chain message, it has a lot of messages, all submitted by this call. So yeah, if we are not lucky, maybe it's not very easy to find out which are the benchmark result. Like for this is Phala Mining update. It just show the heartbeat. It also contains the benchmark, but that is the continuous benchmark. So yeah, and this is mining report, and this is mining report as well. So yeah, it's not easy to just find out which are the benchmark result. But anyway, so after the benchmark, it will send the results back to the blockchain, and then the blockchain will calculate the initial the minimal stake. And well, this should be the V, it should be the minimal stake. And then when the miner is already registered on the blockchain, then we are going to start mining, right? So a miner, is possible to submit a transaction to the blockchain to indicate he's willing to start mining. And after the mining is started, then there's another process. There is a special worker called GitKeeper. GitKeeper is responsible to track the token economy running on the blockchain. So the GitKeeper knows how much you stake for each miner and what is the current level and all the parameters of each miner, because it's required to calculate how these miners are rewarded and how these miners are slashed. And of course, when the miner are mining for some time, the gatekeeper can create a payout to the miner, and after that you can get the payout. And actually, we can also got the payout. We can also see how these payouts are happened on the blockchain. And this is the Polkadot.js app. And as you can see, there are a lot of things happening on the blockchain. And among them, we can always see something called Phala Mining miner settled. And if I make it larger, you can see this is created by also sync off-chain message. And this is this message is submitted by the gatekeeper. And each message contains the settlement of multiple miners. And as you can see, miner settled means this miner is settled. And the first parameter is how much you can get. But this is not the human readable amount. It should be converted to the far balance. And the second is the payout. The first is the V, the second is the payout. So at every block, the gatekeeper will update all these tokenomic parameters as well as make the payouts, actual payouts to the miner. And as a result of the payout, as you can see, this miner got how much? It's 0.313 FA, because this million FA, so 0.3. Yeah, so that's what happened during the mining. And if you don't want to mine anymore, you stop mining on the blockchain. But stop mining doesn't mean the miner will be you can take out the stake immediately, because there is a mechanism to observe the blockchain to check if there's anything bad happen from your miner. For example, you keep you keep up and down. I mean, you keep responsive and become unresponsive. This disturbs the network, and we will have a period called cooling down. So in the cool down period, if there's anything bad happened on the blockchain, detected or reported, then we have the chance to slash your stake. So right after you stop mining, there's a 7-day cooldown period. And after the cooldown period, you can reclaim the stake back. So if like there's nothing bad happen in your miner, then you can reclaim all the stake back. But if there's anything bad happens, then you can only reclaim a portion of the stake back because some amount will be slashed. Yeah, so this is the very basic mining, but it's only the minimal version because there are still some problems we're going to deal with. So this is a very interesting diagram chart, and this shows the tokenomic, and every miner has a value called V, the value promised associated with the miner. It will gradually grow, and in the first chart, as you can see, there's an initial V calculated based on your performance as well as your stake. So the more stake or the higher performance you have, the higher initial V you are going to have. But as time passed, the V will grow because you stay the longer you stay in the network, we consider this worker the more loyalty to the network and the better credit this worker earned. So the V increase, and the more V you got, the higher V you got, the higher payout you can get from the network. But if we scale, if we zoom in this chart, and in some maybe if we check it in the hour scale, then you can see it's it's like up and down. It goes up because you accumulate some V. It goes down because you got the payout. Each time you got the payout, the V decrease a little bit. So that's how the tokenomic run. But tokenomic is not a major topic in today's talk. So let's just back in mining itself. Yeah. So the first problem we have to solve is to distinguish if a miner is online or is offline, right? Because we always want to reward the online miner and punish these offline miners. To solve the problem, a very easy way is to introduce a concept called heartbeat challenge. So what is a heartbeat challenge? So we somehow send a request or a challenge to some miners, and we ask this miner to respond the challenge within a fixed amount of within a fixed period. For example, the period can be maybe 2 blocks, 5 blocks, or 10 blocks. And our Ancala network now is configured as 20 blocks. So it's not a super strict requirement for the worker. So as long as you can reply within 20 blocks, then you are good. So this is a really simple mechanism, and it turned out it's really it's also very powerful. But if there are maybe 10K or even more a number of the miners, then we really don't want to send out the heartbeat request for all the miners at every block, because that will be very huge. The blockchain is not capable to process thousands or even 10,000s of transactions within one block. So this introduced the performance issue. So how do we solve this problem? So the solution is called probabilistic payout, and the concept is very similar to Bitcoin mining. On Bitcoin mining, a miner just keep mining on the blockchain, and people are just like rolling the dice. And the more powerful the machine you have, the faster you can roll the dice. And the dice can produce a number. It can be a number ranged from 0 to a very huge number. That is how to say that? It's the power of it's the power of 2 and the magnitude is 2 and 56. So yeah, I don't know how to say that in English, but yeah, so from 0 to 2 power 256, this amount of the number. So you roll a dice, and if your dice, the number you produce is low enough, then you can win the block. And the challenge is really, really hard to find. It can dynamically adjust the difficulty of the challenge. So it's always supposed to find a single solution to the challenge in 10 minutes. So that's why the block time of Bitcoin is 10 minutes. So for us, it's slightly different. We also ask all the miners to roll a dice, but it's not like Bitcoin mining. They don't do the hashing. They just check. We just create a random number on the blockchain, and all the miners, as long as you are registered on the blockchain, you got a chance to claim you are the winner of this block. And at every block, we're going to pick out 20 winners. And actually, the amount of the number of the winner doesn't matter a lot. It just affects how soon or how late how frequently you can get the reward. But the actual amount of the reward is still calculated based on how long you stay in the network. So here we have a probabilistic way to always pick up 20 miners at every block. So theoretically, we only require 20 transactions every block to run the heartbeat. And we can, because like if you are a worker, you cannot predict when you're going to be challenged. So you have to keep online for a long time. Otherwise, if like you are picked and you are not online, then you're going to have a hard time because we slash hard. So combining the probabilistic payout and the heartbeat, we can only pay the miners when you successfully answer the payout, the heartbeat challenge. And if you cannot answer the challenge, you are going to switch from the mining status to unresponsive status. So like if you check on the app, and there is a page called mining, but well, on my account there's no any mining worker. But if like you're a miner and you can see your worker show in this section, and there is a column called state, and you can see if it's ready mining or is already unresponsive. If it shows unresponsive, in theory you're going to be slashed. But now we didn't open the slash on our blockchain because we need to like wait a few more weeks before we enable slash. Now there's no slash. But anyway, if you are unresponsive, you got no payout. Yeah. And like if you are unresponsive, and how do you recover? You just make sure your miner is running normally, then it will send the response back to the blockchain, and the gatekeeper will try to recover you from the unresponsive state back to the mining state, so that you can get the rewards just like usual. Yeah. So this is online or offline. And now we have the basic mining, and we have the mechanism to pay out and detect online or offline. Then what are the other problems? And actually, this problem is not, I think it's not fundamentally a problem, a technical problem, but it's more like the requirement we should fulfill in the network. That is staking. So it's always possible that there are some miners, they have the good knowledge and they can run the farm very well, but they don't have the token. And there are also a huge amount of the hodlers, they hold the token and they want to earn from mining. So how, this creates the demand and the supply. The demand is the miners. They need token to mine, to stake. And the hodlers, they have the token. They want to provide the token to the miners, and then they can earn together. So the solution is very simple. That is lending. We can somehow create a way to allow these hodlers to lend their token to the miners, and then they can collaboratively mine on the network. And the solution is called stake pool. So basically, we can, on the protocol level, we create a decentralized way to connect the miner and the stakers. We also call the staker delegators. So the delegators put their money into the pool, and then the miner can also use the pool to fund their miners and in order to run the mining process. So the internal, how do we implement such stake pool? And let's back to this picture. And as you can see, in the stake pool, it accepts multiple delegators to provide the token. And they pool all these tokens together inside the stake pool. And on the other hand, the stake pool funds some workers. It can be just a single worker or a few or multiple workers. So when we are talking about basic mining, the worker can start mining and keep getting rewards, and then after stop mining, you can take back the stake, and this is the happy path. And if something bad happened, then your original stake can also be slashed a little bit. So if after we introduce the stake pool, all these concepts also apply, but this time it applies to the pool, and it should involve all these delegators. So we have to solve all these related things. First is contribute, and on our front end we call that delegate. So anyone, as long as you have the token, you can delegate to a stake pool. And after you delegate to the stake pool, the pool, there's the owner of the pool, right? The owner creates the pool, and the pool can also the owner can also add a few miners to the pool, right? So after the contribution, the pool owner can start mining, and this is the pool owner only control the pool, and the pool serve as a standalone miner to control all these workers. And of course, after it starts mining, a few tokens in the pool are assigned to the worker as the stake. So this is what happened after contribute. And from the delegator's perspective, you also want to withdraw the token from the pool, because like sometimes you think, well, this pool is not good enough, I want to switch to another pool, or you think it's time to take back the token, and then you can call on delegate on the pool. And if like you check the app, we have the delegate page, and this is like a full this is a full list of all the pools, and you can see that there are owners, and there are commission and delegated free delegation. So let me explain them one by one. The first is delegated. It means that all the token received by the pool. So whenever you delegate some token to this pool, it will show in this column. And some of the delegated token are already used by the miner, and there are also some not used. So the not use the token, we call it the free delegation. So like now you're going to start a few more miners, then you're going to use the token listed under this column. So like if you want to stake maybe 4,800 Pha, then you are good to go. But if you want to start a miner with maybe 5K Pha, then there's no sufficient token from this pool, right? And there's also another concept called releasing token, and I'm going to talk about this a little bit later. But another very important concept is called commission. So like think about if we do solo mining, you own your miner and you stake for yourself, then all the reward goes to your own pocket. But if like there is a pool and multiple delegators, they contribute to the pool, then it's very natural to redistribute all the reward from your miners back to this pool, these stakers, these delegators. And before your reward and how the reward is allocated within all these delegators, it's just the pro rata. So basically, the more you stake, the more you can get from the reward. So whenever you stake to the pool, you get a share in this pool, and the reward is distributed based on the share. But before the allocation of the rewards, the pool owner, or usually it's the miner itself, they can claim some commission first. So for example, they can claim 8% of the reward before distributing it to all these delegators. And it can range from 0 to 100%. So some people, they want to get lower commission. So for this one, it's 8%. But someone, maybe they just want to get all the reward. They don't want to distribute to the delegator. Probably they are some, I don't know, some mining farm. They delegate to themselves and they do the centralized reward distribution. So yeah, it's very flexible. Yeah, so that's the mining reward and their commission. And finally, there are also the possibilities to get slashed, right? So if a miner gets slashed, then we're going to distribute, we can see that distribute, or we just put the responsibility back to these delegators. So by delegating to someone else pool, you don't only get the reward, but you also bear the risk. Because if the pool operator doesn't operate the pool very well, the miner gets slashed, then all the delegators can also get slashed. So if like you are familiar with Polkadot, NPOS, or any other proof of stake blockchain, this is a very similar approach. So basically, if you stake and the operator doesn't do well, then you have the risk also get slashed. And this is also pro rata. Yeah, so we just use a pool as another layer built on top of the simple version of the mining, and then we combine them together and we can connect the miner as well as the delegator to make them collaboratively mining. So, and actually on our code in the implementation level, we have 2 pallets. So each pallet is just a model on our blockchain. One is called Phala Mining, another is called Phala Stake Pool. And they are connected based on a concept called mining subaccount. So let's take a look. So if you check like, so this is the Polkadot.js page. And if you check chain state, this is reading the data on the blockchain. Or if you check extrinsic, that is to send the transaction to the blockchain. You can always see there are a few Phala related module. The first one is like Phala mining. And you can find out some very basic parameters. For example, the cooldown period, and this is the seconds for the cooldown period. And you can also check like online miners. This is the number of all the miners, including those online and those unresponsive. You can also check like the tokenomic parameters. So it has all the parameters we defined on our tokenomic paper, and some of the parameters are not human readable, but you can always use the code to convert it from this number to the actual number. And as you can see, the slash rate is 0 because now we have disabled slash. And there's also the heartbeat window, that is the 20 blocks I have mentioned in this talk. Yeah, and there are also miners, right? So there are a lot of miners. Let me just randomly pick one. So there are too many miners. So I'm just going to pick up a random one. Wait a minute, I have a table. I'm just going to take find a random one. Yeah. Yeah, here we go. This is a miner, so let's just take. Yeah. So as you can see, on Phala mining, this module, we have a concept called miner, and this miner, the key is account, and the account is not just some account in your wallet. It's actually a virtual account generated by the stake pool, and you can somehow try to figure out the miner account associated with your miner. But yeah, if you check the miner, then you can see these are the data associated with miner. First is the state. Now it is ready, meaning this miner is not mining at all. And it has VE. VE is the initial value of V, and V is the latest value of V. But when the state is ready, then all this data are just the historical data. And as you can also see, in here we also have a field called benchmark. It shows how much you can, just the benchmark readout. P init, initial P, is the initial benchmark. So it's it shows how much you can run in one block. Like this one can run 1,476 iterations per block. And the second is P instant. That is when you are keep mining on the blockchain, we keep benchmarking your workers, and it can be a bit higher or a bit lower than the initial benchmark, but it should roughly match the initial version. It also shows like the iterations and the time. Yeah, and also there's states. So you can check how much you have earned from mining in this mining session. But if you stop and start again, then this state will be reset to 0. So this is miner. Then we can also check these workers. The workers are listed in the registry. So like we can just randomly pick a worker here. You can see this is the key. It identifies your identity. It shows the operator. That is, whenever you want to add a worker to the blockchain, you authorize some pool owner to operate your worker. So here, when you start the worker, you specify who you want to grant the permission. And it also has the initial score. It should match the one in pinit. But I just copied some random numbers, so they're not necessarily to match. Yeah, and that are the mining and the registry. And another layer is the stake pool. The stake pool only focus on how to accept multiple delegators stake, pull them together, and allow the worker, the miners to start or stop workers. So on stake pool, you can see this is the pool account. It already has 105,000 pools, 1,500 pools, and you can also check the pool details. Like let's check the first pool 0, and it shows the pool owner. It has the total shares, total stake, free stake, as I mentioned, and it also shows the workers in the pool. And in this pool, it only has one worker. Let's just randomly check, maybe 1, 2, 3, another pool. This pool also has one worker as well. Some pool may have huge amount of workers, and we support up to 200 workers within a pool. And whenever you put a miner into a pool, the pool will generate a sub account as the miner account. And if you are interested, you can take a look at our code. So it's basically a hash of the PID, the pool ID, and the worker public key, and use that to produce a virtual account. So that's how the stake pool is connected to Phala mining module. Yeah. All right. So this is basically how the stake pool is created. But there's another problem we haven't mentioned. It's about trust. So like if we go back to this page, and you can see the delegator delegates their token to a pool, and the pool owner control how these tokens are used to mine for workers, right? So there are two roles. One is the pool owner, another is the delegators. The delegators may want to withdraw the token at any time, but if we like the delegator and the pool owner are not trusted with each other. So like if we allow the delegator to withdraw their stake immediately, it means that as long as they withdraw, these workers cannot mine anymore, right? Because workers require stake to mine. So if like we allow delegators to withdraw the token immediately, then the pool owner is not fair to pool owner, because the pool owner maybe they work very hard to set up a lot of workers, and then the delegators just jump in and start mining, and then withdraw the funds. Then all your worker will be in the cooldown period. This creates like a lose for the pool owner. But on the other hand, if we purely rely on the pool worker to decide when to release this token, it's also problematic for the delegators, because the delegators, the pool owner may decide to just run forever, and delegator don't have any chance to get back their token. So this is also a very big problem. So to solve this problem, we think basically we shouldn't allow anyone to trust each other. The solution is we call the delayed withdrawal. We allow the delegators to create the withdrawal request at any time, and this request will be queued within, we call them a withdrawal queue, and the withdrawal queue is served as a first come first served way. So basically, if you ask for withdrawal first, and then there are some free token released either by some other stake to the pool, so that their stake goes into the pool and your stake got released, and you can get your stake back. And or maybe the pool owner just want to shut down a few miners, and after 7 days, then you can get the reward, you can get the stake back, right? So we have a queue for all the withdrawal requests. The first one will be served first, and then yeah, they will be fulfilled one by one as there are free stake. But what if the pool owner just doesn't stake, just doesn't react to the withdrawal request? So we have a 7 days grace period. We allow the pool owner to check if there's any not fulfilled pending withdrawal request, and if after 7 days grace period these requests are still not fulfilled, then the protocol will try to shut down all these miners. So when all the miners are shut down, all the stake will be released after the cooldown period. Then you can get back your reward. So here are the happy path and the bad case. The happy path is you request for withdrawal, and if there's new stake, then you get unlocked. If there's any stop workers, then you also get unlocked after the cooldown period. The bad case is that if after 7 days of grace period, there's still no enough releasing stake to cover your request, then the entire pool will be forced stop. And this is also a punishment to the pool owners, because it will be very hard to set up another pool right after all these workers are stopped. So yeah, this stake will also be just wait there, and for after 7 days cooldown period, and everyone can claim their stake back. And there's also another concept I haven't mentioned, that is reclaim. So reclaim is basically a way to take back the stake after the cool period. So withdrawal and reclaim are two separate processes, and they are not connected with each other directly. Reclaim means that if there's any miners, and the miner are in the cooldown period, and after 7 days, then it's eligible to get back, release the token, and we require someone. It can be anyone, just the pool owner or delegator or anyone else. They can use a function on the blockchain to trigger the reclaim of the worker, of the miner, and then the miner will be released. And after the release, the withdrawal will be fulfilled. And sometimes maybe the pool owner reclaim the worker for you, but sometimes if as a delegator, nobody reclaim that for you, then maybe you're going to do it on your own. Yeah, on our front end, there's also the button to reclaim, but yeah, it's not on this page. If I'm a pool owner, there will show some workers in this section, and in the action menu, there's a button to reclaim if like this worker have been waiting for 7 days after the cooldown period. All right, so just a lot. So put everything together, we have designed a way to serve our purpose, which is to build the Web3 cloud. We want to attract as many workers as possible to provide the service to the developers. So we're going to design a mechanism to reward these workers, and at the same time, we also want to make sure all these workers meet their SLA. So we have the mechanism to check, to challenge the workers, make sure they are online. And we have developed the probabilistic payout algorithm to ensure this the payout and the challenges can be fit into the performance on the blockchain. And finally, we also introduce a module called Stake Pool to help people solve the mining liquidity problem. It can help the miners and the stakers combine them together to help them to collaboratively mine and earn the reward together. Yeah, so that's everything in this talk. And I would also like to mention this talk, we all focus on the mining itself, not the tokenomic, nor the Phala architecture. So in our last tech talk, the tech talk 01, Dr. Shunfan Zhou was talking about Phala architecture. So if you are interested how these miners talk to the blockchain and how blockchain use these workers to dispatch the task and run the applications, you can take a look at our last tech talk. So it's already available on our podcast. So you just don't miss it if you are interested. And finally, yeah, again, the next event will talk about our hackathon happening right now. And the hackathon starts in the beginning of this month, and it will last by the end of this month. So, like, if you are interested in how we can build on Phala network, just don't miss it. The next tech talk, and probably you can also have a try. We have the easy challenge. Maybe you can also you can just finish that within a few minutes. And we also have the hard challenges. You can try to challenge yourself. We have bounties for that. All right, so yeah, that's all from my talk. Thank you for listening. I think we're going to check. Are there any questions? There are 3 questions I have. Let's just go through them one by one. First is, does every miner need its own mnemonic key? Yes, all the miners require to run the mining client, and the mining client needs to talk to the blockchain. And the way they talk to the blockchain is to send the transaction. And to send transaction, of course, you need an account with some Phala token to pay for the transaction fee. So yes, so all the miners need the mnemonic to send the request, send the transaction to the blockchain. Yeah. The second one, does every miner need an official IPv4 or IPv6 address? The answer is no. Actually, now you can already mine without any public IP address, but there are some caveats. First of all, if you do solo mining, then you're going to run a full node, and then you run the mining client. The mining client is connected to the full node. I think neither the full node or the mining client require you to have some public IP address or even static IP address. But as far as I know, there are some problems in the full node itself. So if like you run the full node behind NAT, I mean like within your home internet behind router, then it's typical. It's typical like you have you run your full node behind a router, so you don't have a public IP address. But then the problem becomes you may get a very low peer number. And I think this is pretty similar to you do like BitTorrent downloading or Catamailer downloading. Like if you have a public accessible port, like you can do the port mapping, or you can just assign the public address to your full node directly. As long as the other full nodes can connect to your full node, then you can get up to 50 peers. But if you have no public access, then you are going to have a hard time to synchronize the network. And like if you got really low peer number, then it's likely at some point your full nodes will be lag behind. And then like if it happens, the blockchain pick your worker, send to you a heartbeat challenge, then this become a problem, right? Because you are not synchronized to the blockchain. Your worker doesn't know there is a challenge. Then you become unresponsive, and then you lose the reward and probably can get slashed. So I think the simple answer is there's no official IPv4 IPv6 address requirement, but it's a preferred choice. And if you don't have the public IP address, that's fine. You can try to do the port mining, just like BitTorrent downloading. Yeah. Okay, this is the second question. The third, when delegating my file to a pool, how can I check how healthy my pool is connected to the network? Which parameters to check? That's really a good question. So I think from the delegator point of view, of course, it's not like you just check the higher APR, the better, because like a miner without, a very careless miner, they can also create a really, really high APR by maybe like just assign a very, very low commission. But it doesn't mean this miner is a responsible miner. Because like some miner, as far as I know, some miner, they do the track, like they set a very low commission, and right after you delegate to this pool, the delegation reaches to 100%, so you get nothing. So these are all the bad miners. And actually, we do have some discussion on our GitHub page. So if you are interested, you can check a look at this problem, like this one. But a very important aspect you need to consider is that this pool is already a very stable pool, and it operates. It doesn't have a very ridiculous low commission, and it runs smoothly. It can give very steady, stable payment to the delegators. So now I don't think there's any very good way, unless you check the block explorer to check all this payout history. But we are working very hard to deploy a backend so that now, like, we already have the analytics page. But if in the future, maybe very soon, we have the analytics for every worker and every delegator, then you can see if these delegator are like good miner, they can give very stable payout to the worker, to the delegators. So I think this is the biggest factor the delegator should consider. So the more stable, the better. And after that, you check which pool has the best APR. Yeah, so healthy. Yeah, and another thing is how many workers are already in this pool, and it's already reflected in the APR. Yeah, so. Oh, another thing is remaining. Remaining means the remaining allocation for you to stake. Like if for some high APR pool, there's no remaining or very, very small remaining allocation. So you don't have, you cannot stake to this pool. So like for this pool, it has 16K FA. So you can stake up to 16K to this pool. But for another pool, for example, this one, it only have 1 FA in the remaining. So you can only stake one file to this pool. So it's not very useful. So a lot of parameters to explore. And if like you have any good ideas, I suggest you share the good ideas or your concerns on our forum. We have the forum page to like just talk with each other. All right, so this question. The last question, if a miner's internet connection goes offline accidentally, can the miner restart their internet connection and start mining again right away? Or will their file be held up for 7 days? A minutes ago, Steve, that question is for a miner doing solo mining. Ah, good. Yeah, I have to cover this in the tech talk, but yeah, it's a very good detail. So whenever a miner goes to unresponsive state, the miner itself in the client is still in the pending state. As long as it's connected back to the blockchain again, it will immediately send the response back to the blockchain to just report to the blockchain, say, hey, now I'm back online. So just put my status from unresponsive back to mining. And so here you need to make a decision. So like if you think it's possible to recover back online very soon, then my suggestion is just to do nothing. Let the miner to connect back to the blockchain, and then it sends the response, and the miner will be back to the mining state. But now we don't have any like we don't have any slash mechanism enabled. So theoretically, if you just stay offline for a long time, you don't have any loss. But in the future, when we enable slashing, then this become a problem, because the longer you stay in unresponsive status, the more slash will be performed on your account. So like if it's just a very short amount, very short period, maybe a few seconds or a few minutes, I think is good enough to just connect back online. But if you think probably like you got a power shortage for a few days, then I would suggest to you to stop mining. It will immediately stop your miner from being slashed. But you are going to wait for 7 days before you get the stake back, and then you can use this stake for maybe the next mining session. So yeah, it's really a good topic, and there are different strategies to use. But basically, yeah, it's up to you to decide. All right. Is there any other question? I think no. Yeah, most of the questions are already answered. Okay, cool. Nice. All right, so yeah, it's already more than 1 hour. So yeah, let's keep in touch. So if you have any other questions, don't hesitate to ask in maybe our forum. We also have our Discord channels and the Telegram channel. They are connected together, so you can ask whatever software you want. So we are always in the group to answer your questions. And yeah, if you have other good suggestions, feel free to make a post on our forum or submit an issue to our GitHub if it's more technical. And yeah, lastly, don't miss our next tech talk. We're going to talk about how to send out HTTP requests from our smart contract. Yeah, thank you, everyone.